Okay, lesson 3 is multiplying and dividing. Okay, so example 1. 4 root 3, 2 root 5 minus root 7. Okay, so how does this work? So if we have a number in front and in brackets, we have to distribute throughout the brackets. So you're essentially going this times this, and then this is also times by the second term. Okay, so now what does this come out to be? So this is 8 root 15. So coefficients go with the coefficient part, roots go with the root part. So 8 root 15. Then the second term has a -4 coefficient, and the radical part is root 21. And that's your final answer. Example 2, we'll do one more of those. Okay, so in this one, ready? The first term, we got an 8 and a root of 70. The second term, I get a 2 times 5, so that's a 10, and I get a square root of 49. Okay, I see something here. This square root of 49, I can actually change to be a 7, and thus I can change this term to just be 7d. So your final answer would be 8 root 7d plus 7d. Example 3, 11 root 33 plus 8 root 12 minus 16 root 27, divide by 2 root 3. Okay, so this is kind of just the opposite of what we were doing. You need to take every term and divide it by 2 root 3. Okay, so this would become, well, 11 divided by 2, that's not a nice pretty number, so you can leave it as a fraction, 11 halves, or 5.5, that does not matter. Then take the radicals, so 33 divided by 3 is 11. So the radical is root 11. Second term, positive 8 divided by 2, so that's a 4. And the radical part is 12 divided by 3, so that's a radical of 4. Last term, this is a -8 coefficient. 27 divided by 3 is 9, so root 9. Okay, I see a bunch of stuff here. So this root 4 I can change. So that would become a 2, and so that term would become an 8. This root 9 I could also change to be a 3. So that would be 8 times 3, so that would be a 24. So my final answer is now, because those are two constants, I can put them together. So 5.5 root 11 minus 16. Example 4. 2 root 3 plus 8 times 5 root 7 plus 2. Okay, so now we have two binomials. So this means we have to do the whole FOIL system. Okay, so first times first. 10 root 21. See it? 10 root 21. Outsides. So the outsides, coefficient 4, root 3. Insides, we have coefficients of 40, roots of 7. And the last, we have plus 16. Okay, now we just check, is there any roots that we can break down further? Is there any similar roots or coefficient or constants to put together? And there is not. Okay, what if we do this? 5 root 3 plus root 7, and then a 5 root 3 minus root 7. Okay, so let's do a FOIL. First times first is 25 root 9. Outsides, negative 5 is in the front, root 21. Insides, positive 5, root 21. And the last, positive times negative, is negative. 7 times 7 is 49, so root 49. Okay, so what happens here with the negative 5 root 21 and positive 5 root 21? Those end up canceling, right? I noticed that this root 9 can be changed to a 3. So 3 times 25 is 75. And then root 49 can just be 7. So my final answer is 68. Okay, so if you ever see something like this, these binomials are the same except for the plus minus. So it's that same concept of the difference of squares. So when you do a difference of squares, the plus minus, that is always going to cancel the O and the I part of it. Okay? So that's what happened here. The outsides and the insides canceled. So when you see this, that's always going to happen. So instead of really doing a FOIL, you can just do a FL. Okay? And the word that we use is called a conjugate. And we're going to talk more about that. Okay? So this is the conjugate of this one because it's the same binomial with the opposite sign. Okay, example 6. Root 5 plus 4 root 10 times 2 root 3 minus 3 root 7. Okay, so let's do the whole FOIL. So first we have coefficient 2, radical 15. Outsides, we have coefficient negative 3, root 35. Insides, coefficient 8, radical 30. And the last, coefficient negative 12, root 70. Any similar ones? Nope. Any ones that we can break down? No. So then we are done. Okay, last example. So example 7. Alright, we have root 5 plus 4 root 10 squared. Okay, so what are you going to do with this one? I suggest that when you see something squared, you don't try to shortcut, just rewrite it twice. Okay, so that's really what you're doing. Now you can FOIL that. So root 5 times root 5 is root 25. Outsides is 4 root 50. Insides 4 root 50. And the last would be 16 out front and the square root of 100. Okay, so root 25 can break down just to be a 5. The root 50s can combine. And root 100 can also break down. So that becomes 660. So now I can see that this would become 165. I can put those two together. Now I also see this. Root 50 can break down. Root 25 times 2, root 2. Don't forget about the 8. Now this root 25 can change into a 5. So this would become 40 root 2. And that's your final answer. Okay? Sometimes you might start to recognize some patterns here. Root 10 times root 10. I know that I got you to go to root 100 and then down to 10. You can start to notice that that would just be 10. So for instance here we had a root 5 times root 5. That just equals 5. Because essentially what you're doing is root 5 squared, which cancels. Okay? So if you recognize that pattern, that's fine. If you want to keep going this long way and then back to 5, that's also fine.